Hello friends, welcome to this video session. The topic that we are going to cover in this session is trends in modern periodic table. We will discuss various trends about valency, size of atoms and metallic, non-metallic properties one by one across the period and down the group. Let us first begin with the trend of valency. On moving from left to right in a period, the number of valence electrons in elements increases from 1 to 8, and therefore their valencies can be found by the number of these valence electrons. So, on moving from left to right in each short period, the valency of the elements increases from 1 to 4 and then decreases to 0. You know that the valency of any element is determined by the number of valence electrons present in the outermost shell of its atom. Now, let's talk about the valencies of the elements in the group. All the elements of a group of the periodic table have the same number of valence electrons. For example, all the elements of group 1 of the periodic table like lithium, sodium and potassium have one valence electron in each of their atoms. The atoms of group 1 elements, lithium, sodium and potassium have one valence electrons and therefore they have valency equal to 1. All elements of group 2 have 2 valence electrons and hence valency is 2. Valency of group 13 is 3. Valency of group 15 is 3. Valency of group 17 is 1. Let us now discuss about the size of different atoms in a period. On moving from left to right in a period of the modern periodic table, the size of atoms decreases. As we move from left to right in a period, the atomic number of the elements increases, which means that the number of protons and electrons in the atoms increases. Due to large positive charge on the nucleus, the electrons are pulled in more close to the nucleus and the size of atom decreases. Thus, in any period, the alkali metal atom like lithium, sodium, potassium, etc. is the biggest in size, whereas the halogen atom like fluorine, chlorine, bromine, etc. is the smallest in size. Now, let us discuss the atomic size of the elements in the groups. As you see, going down the group, the size of the atoms increases. So, the smallest atomic size will be found at the top of a group, whereas the largest atomic size is found in the lowest part of the group. Let us see the reason behind this trend. When we move from top to bottom in a group of the periodic table, a new shell of electrons is added to the atoms at every step. In this way, the number of electron shells in the atoms increases gradually, due to which the size of atom also increases. Now, we will first discuss the metallic or non-metallic character in a period. On moving from left to right in a period, the metallic character of the elements decreases. At the same time, the non-metallic character increases. On the left side in a period, we have metals, and on the right side, we have non-metals. Some elements in between the metals and non-metals, these form a zigzag line, separate metals from non-metals. The borderline elements, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, are intermediate in properties and are called metalloids or semiconductors. Metals tend to lose electrons while forming bonds. That is, they are electropositive in nature. Now, let's discuss the trend of metallic and non-metallic character in the groups. Non-metals, on the other hand, are electronegative. They tend to form bonds by gaining electrons. On going down in a group of the periodic table, the metallic character of elements increases. For example, when we move down in group 1, the metallic character increases from lithium to francium. These trends also help us to predict the nature of oxides formed by the elements, because it is known to you that the oxides of metals are basic and that of non-metals are acidic in general. Friends, in this video, we studied the trends in the modern periodic table.